discussion of functions of several variables, we also discuss here level curves. And so one way to visualize a function of two variables is to consider z as a scalar field. That is, the vector or the number z is just a number. The variable z, excuse me, is just a number. And if that be the case, then you can look at z with respect to various numbers, and you can see the so-called contour or the shape of the curves or the lines that it may show. This is used a lot in mapping, whether it's for geography, for meteorology. They use this idea of level curves, military navigation, space exploration. And so how would you take a map and transfer that on a two-dimensional surface, whether it's computer-aided design and graphic? It is used here, the so-called contours are shaped in what we call level curves, just a two-dimensional depiction of a 3D space. So say, for example, if you have a region here, and it can be noted that certain colors would denote the height or the depth of the region that you are trying to illustrate on a 2D map. So if you take the surface here, this top part of a sphere, and if you transfer that with level curves, this is how it looks on the right side. Likewise, if you take a hyperbolic paraboloid, and if you transfer this 3D image to a two-dimensional space, then if you're looking from the top view, that's what it looks like. And so if that be the case, we look at some problems here where you want to sketch the contour map of the surface using the level curves. So z becomes c. And so we have x plus y is equal to c. This implies that y is equal to negative x plus c. And then from there, based on the various values for c, so here this is y is equal to negative x, y is negative x minus 1, y is equal to negative x, here y is equal to negative x plus 2, then y is equal to negative x plus 4. So if we look now at the graph, so if we take the first one, it's a negative slope with y-intercept at negative 1. And then for c equal to 0, it goes to the origin. Then c equal to 4, negative 1, 2, c equal to 2, excuse me. color purple, and then C equal to 4. Let's keep purple for this guy. Replace Z with C. So we have X plus 4y squared is equal to C. So here we have X plus 4y squared equal to C. If C is 0, we have X plus 4y squared is equal to 0. If C is 1, this is X squared. X squared plus 4y squared is equal to 1. If C is 2, then X squared plus 4y squared is equal to 2. If C is 3, X squared plus 4y squared is equal to 3. And then if C is 4, X squared plus 4y squared is equal to 4. I'm going to simplify this so that you see that these equations are ellipses, or ellipse in the 2 space. It's a 3-dimensional graph, but for the contour, when C is set with Z is set to equal to C, a number, this is now restricted into the 2-dimensional space. So if we did that, and to try to blow it up, so you can see what's happening. What it looks like is this: X squared plus, for the first one, this is y squared over 1/2 squared, and that's equal to 0. This was for C equal to 0. And so this is an ellipse with the x terms tending to plus or minus 1, and then the y values tending to plus or minus 1/2. For the next one, x squared plus 4y squared equal to 1. That is x squared over 1 squared plus y squared over 1/2 to be squared is equal to 1. This was for C equal to 1. For the next one, for 2, we divide through by 2, and so we get x squared over 2 plus, here this is 2 times y squared is equal to 1. And that implies that we have x squared over the square root of 2 to be squared plus y squared over 1 over the square root of 2 to be squared. Once you square this 1 over the square root of 2, you get 1/2, and then when you flip it, it becomes the 2 back upstairs again. There, it's equal to 1, and this was for C equal to 2. Then for C equal to 3, you have x squared plus 4y squared equal to 3. Divide through by the 3. So we get x squared. Just go ahead and just write it while we're here. This is the square root of 3 to be squared plus This is y squared. And what we have here is the square root of 3 over 2 to be squared is equal to 1. And this is for c equal to 3. We check that. This is x squared divided by 3. And this is y squared divided by 3 over 4, which becomes in simplified form 4y squared divided by 3. Then the last one, x squared plus 4y squared is equal to 4. Divide through by 4, we get x squared over 2 to be squared plus y squared over 1 squared is equal to 1. And this is for c equal to 4. Okay. So let's put the graph down here. Now, it's easy to plot the plus or minus 1, plus or minus 1/2 for the c equals 0. Easy to plot the same thing for c equal to 1. It gets kind of technical when you want to try to plot here the square root of 2 plus or minus that, and then plus or minus 1 the square root of 2 for y. But I have a trick. They're gonna start with the small dimension of plus or minus 1 for x, plus or minus 1/2 for y. Then they end up with the larger value, plus or minus 2 for x, plus or minus 1 for y. So we're starting in that fashion. So x is plus or minus 1, and then here the y is plus or minus 1/2, but it's c equal to 0. So here this guy is at the origin. And then for the next one, x plus or minus 1, y is plus or minus 1/2. So we're going to say that this is 1 plus or minus 1. I have an ellipse there. Then for the next one, it's a little bit more refined than that outwardly. And the next one is a little bit more refined than that, where the x is approaching the 2 and the y is approaching 1. I guess that color is okay. And it's supposed to be uniform. But you get it. Yeah, it's uniform, all right. Boy, I tell you, I can do better. Let's see. And then the last one, where x is plus or minus 2 and y is plus or minus 1. Now, I think I can draw that better. I'm getting sick of that. Now, I do have these helps with the computer-aided graphs and these things. I guess I'm just country. So that's the first one. So we got 1, 2, 3, 4. Okay. just leave it like that, all right? Here's a good one. So here, f of xy is z, so that's c now. So c is equal to the square root of 9 minus x squared minus y squared. Square both sides, and so we have c squared is equal to 9 minus x squared minus y squared. That gives us x squared plus y squared is equal to 9 minus c squared. So if we take the values of c, plug those into the equation, and the equation is the x squared plus y squared is equal to 9 minus c squared. So if c is 0, we get x squared plus y squared is equal to 9. If c is 1, we get x squared plus y squared is equal to 9 minus 1 is 8. If c is 2, we have x squared plus y squared is equal to 9 minus 4, so that's 5. Then if c is 3, we have x squared plus y squared is equal to 9 minus 6, excuse me, and we get 3. So here we get circles. So the first one is a circle with radius 3, and then all the rest of them, they get smaller. I lost my mind. This last one is 0. This is 9 minus 3 squared. Oh, can't believe I did that. You didn't hear that, right? No. We just keep that amongst ourselves. That's right. This is 9 minus 3 squared is 9, so we get 0. Better go back and check my other stuff. 9 minus 4 is 5, and then here this is 9 minus 1 is 8. Good. So this one is with c is 0. We have the radius is 3. It's a circle. Then for the next one, we get a little bit smaller. And I know my circles and my ellipses kind of looked about the same, right? Anyway, the next one where c is equal to 2. Then the degenerate case is at the origin. So this is c equal to 0, c equal to 1, c equal to 2. Okay, the next one. This is x times y is equal to c. This implies that y is equal to c all over x. So c is plus or minus 1. Y is plus or minus 1 over x. When c is plus or minus 2, y is plus or minus 2 over x. When c is plus or minus 3, y is plus or minus 3 over x. And you'll get the idea when we look at the graph. So y is plus or minus 6 all over x. So the basic graph is the basic rational function. For y is equal to 1 over x. So the basic one for y equal to 1 over x, you recall, is this one. Then if it's negative x, negative 1 over x, then it's over here. And then you can refine those for plus or minus 2 over x, plus or minus 3 over x. And when you do that, you have things like this. And you get the idea. Okay, here sketch the graph of the level surface. It's called a surface because here we're talking about a scalar in the 3 space. We assign f of x, y, z to be the number c. So all we have here is x squared plus y squared plus z squared is equal to 3 squared. So it's just a sphere. So it's a sphere with radius 3. Okay. Well, I think that'll do it for now. Thank you.